Hello, everyone. It's a pleasure to be here. So first, a little bit about myself. So I'm currently an associate professor at Georgia Tech School of Industrial and Systems Engineering. I've been here since 2017. I'm also affiliated with Supply Chain and Logistics Center and the Machine Learning Center at Georgia Tech. So my background is in operations research and industrial engineering. For my research, I do research in revenue management, supply chain, transportation, logistics, and machine learning. And in terms of teaching, so I teach in both undergraduate and graduate level. So at the undergraduate level, I teach supply chain economics. And recently, I developed a new course called Tools for Data Analytics, which I will talk about today. And at the graduate level, I teach two PhD courses, revenue management and inventory theory. So a lot of these courses, there's a data component, right? So tools like Vocarium will be great. But today I want to talk more about this tools for data analytics course. So the audience of my course is undergraduates who have a prior knowledge of Python and SQL. So here at Georgia Tech, we have a big undergraduate program in IE. We have 600 undergrads a year, so about 1,600 undergrads in total. And recently, we established a undergraduate major track in analytics, which is becoming very popular. So currently, about 50% of our undergrads are in this data analytics track. So I want to create a course that focuses on tools for data analytics. So the main purpose for my course is I want to fill this gap between some basic Python programming course or SQL, and later they will also take some advanced courses like machine learning. But oftentimes they don't have enough experience to deal with real world data. So in my course, I want to introduce open source Python libraries, libraries like NumPy, pandas, for data processing, matplotlib for visualization, and some machine learning tools, scikit-learn, XGBoost, TensorFlow, and some distributed computing libraries like PySpark. Okay. So for my course, I include both a series of lectures as well as some hands-on lab sessions. So in these lab sessions, the students will have opportunities to work on real-world data sets. I do everything in Jupyter notebooks, so including lectures, lab exercises, as well as assignments, exams. I also have a team projects, so I do all these in Jupyter notebooks through Vocarium. So why did I choose Vocarium for my course? In fact, when I started designing my course, I looked at a lot of solutions. Because there are other existing solutions for cloud-based notebooks. So the first thing I love about Vocarium is integration with LMS, the learning management system, in our case, Canvas, because I really want to create this smoothless experience for students, right? So they can go to Canvas, just click a button, and it will open a Jupyter notebook in web browser for them. They don't need to sign up for any accounts or anything. So this smooth experience makes it easy for students as well as teachers. The second is I can install packages for students. As Sanjay mentioned earlier, we can create a customized Docker image. So basically what this means is, suppose I'm teaching XGBoost or TensorFlow, these machine learning packages. So these packages, they have different versions, and in different versions, so some APIs may be a little bit different. So I want all my students to use the same version. So I can install these packages for students so that they don't have to worry about the version control. And third one, built-in auto-grading, right? So not only can Vocarium do auto-grading, but the grades will be automatically synced with Canvas. So that saves a lot of time for me and my teaching assistant to managing student grading. And the fourth one, so this is a feature I found out during the semester I find very helpful, which is after you release the assignment, as instructor, you can update the grading scripts. So for all my assignments, I use auto grading, so that will provide real-time feedback to students. The student finish some part, they can submit, they can see if they get it correct or not. And despite all my efforts to make sure that all assignments are bug-free, sometimes I do have some errors or scripts. Okay, so if I find out some errors, even after the assignments are released, I can update them, and it will automatically update it on the student side, so they don't have to download the assignment again or redo the assignment, right? So I find this feature very, very convenient. And finally, as instructors or as TAs, we can get access to student workspace. So if they get stuck, we can go into their website, go into their notebook and help them. So also I find these features very helpful. So next, let me show you a few quick demos how I used Vocarium for my class. Okay, so I created a demo course. So as you can see, this is Canvas. This is our course management system. So I'm going to switch to student view. So I click this button. So now pretending I'm a student, right? As a student, so this is usually the place where I upload, course lectures, slides, notes, and I can also add Vocarium notebooks here. So from the student perspective, this is just another course material. They don't need to sign up for an account or anything. So this is very convenient. So let's say we want to do this GPU exercise. So the student click this button, and it takes a few seconds to load. And then now we open a Vocarium notebook in their browser. So here I already prepared this material to students. So courses, I create the notebooks, I can upload data, and the student, they can just open a web browser and it's ready to go. So it's very convenient. So in this demo, we're gonna use GPU to train an XGBoost model. For those of you who are not familiar with XGBoost, it's a tree-based model that has become very popular in recent years. So let's start by, let me make this full screen. Okay, so let's start by running this command. So this exclamation point, so that means we can run some system command in Jupyter Notebooks. So we run this NVIDIA SMI command. As you can see, we have a GPU ready. So here this shows we have NVIDIA A10G GPU. So current temperature is 21 degrees. This also shows the GPU memory. So something that some students don't realize is that the GPUs, these discrete GPUs, they have separate memories from the CPU memory. So otherwise, if the GPU is using the CPU memory, you basically have a lot of time with the I/O. Okay, so we have the GPU ready, and then next, let's load the necessary Python packages. So we're going to use pandas and sklearn. So this is standard, data processing library as well as machine learning library. We're also going to use XGBoost and TensorFlow. So XGBoost is this tree-based model, and TensorFlow is the neural network package. I'm not going to do neural network today, but I will use TensorFlow to download this data set. So here we want to we want to use this fashion MNest data set. So this includes some images of fashion items from a company called Zalando. This is a European e-commerce company. So we download the data set, and let's take a look at the size of this data set. So we have 60,000 images in our training set and 10,000 images in our testing set. So each image is a grayscale 28 by 28 pixel image. We can actually show these images. So I will use matplotlib's IMShow function. Let's just take a look at the first image. So this is what the image look like. You can see this is something like a boot. And we can take it, look at more images. So let's take a look at a sample containing the first 40 images. I'm also going to add the true labels for these images. Okay, so this is the images in the data set. You can see there are different categories. In total, there are 10 different categories. And these are the grayscale images. Basically, the task is I give you input as an image, right? And you want to build a machine learning model to predict the class. Is this an ankle boot? Is this a t-shirt? Is this a dress? Okay, so let's prepare the data. So first, we want to reshape the data from 2D arrays to 1D arrays, right? Because they are images, so essentially it's a 28 by 28 matrix. We want to flatten them so that they become a vector. So we reshape. Now the data becomes just a long vector of 784. Next, so this step is optional, but I find it useful to split the training set further into a training set and a validation set, because if you want to do something like hyperparameter tuning, you can use validation set for that purpose. So I'm going to further split the training set into 90% for actual training and the remaining 10% for as a holdout set for validation. Okay, so now we have the data ready. So let's start with CPU training. So for this, I'm going to just use a basic XGBoost model with the default hyperparameter. So here I will train an XGBoost with 10 trees. So here I specify an estimator equal to 10. So we have 10 trees. And then we're going to fit the model and then predict it on the test set. Okay. Okay, I hit the enter. So now the training starts. So every time we have output, that means we added one tree to the XGBoost ensemble model. So XGBoost is basically a collection of trees. So we want to train 10 trees in total. So you can see every time we add a tree, it takes a few seconds. Okay, so now we're finished. We have 10 trees. And our final accuracy is 85. So we achieve 85 accuracy in our prediction. And in total, you can see here with CPU, we have a training time of 25 seconds. Okay. Next, let's use GPU. Okay, so again, we want to train 10 trees, but this time using the GPU capacity. So in XGBoost, depending on the version, the command may be slightly different. So if you have XGBoost version less than 2.0, you can here in the tree method, you can specify its GPU hist. If you have XGBoost version greater than 2.0, the API is a bit different. So here you will specify device equal to CUDA. So because we're using XGBoost 1.6, I'm going to use the first one. So there's another convenient feature from Vicarium. We can control the versions of these packages for students. Okay. So let's start training. So here you can see it's much faster, right? It takes less than 1 second to add a tree. So we finished training in just 2.68 seconds, so about 10 times faster. Okay, so this allows you to build larger models, train faster to have better accuracy. For example, instead of 10 trees, suppose I want to have, let's say, 50 trees. Okay, so let's run it again. So it's going to take slightly longer, but not much longer, and then we achieve 50 trees, right? So now we have an accuracy of close to 90%. So that's an improvement from 85%. And in total, with 50 trees, it takes less than 10 seconds. So in comparison with CPU, right? With 10 trees, you need 25 seconds. So it's much faster to do GPU. So this is what I show in my course. I have a lot of students who are interested in the capabilities of GPUs. Some students at the beginning of the course, they specifically asked me, Professor, are we going to teach GPUs in the course? Basically I promised, yes, we can do this in Vectorium. So this is my GPU demo.